students, today I will discuss with you the redox reactions. So, what are redox reactions? As you know, the redox reactions are of two types: oxidation reactions and reduction reactions. So, first of all, I want to tell you the redox. What do you mean by redox? Redox is a combination of two phrases of letters. This RED, this RED, RED comes from reduction, and this ox comes from oxidation, oxidation. So when oxidation and reduction reactions are spoken combinedly, then we say the redox reaction. So redox reactions are of two types. One is oxidation and second one is reduction. I have written some equations of the reactions here, that when magnesium reacts with oxygen, magnesium oxide, or you can say oxygen reacts with carbon, or sulfur reacts with oxygen, oxygen reacts with carbon monoxide. You can say in any way, whether you are saying that when magnesium reacts with oxygen or oxygen reacts with magnesium to form a new compound, that is oxide. So it is called as oxidation. So here, from these equations, you can conclude that in all the equations, in all the reactions, oxygen is added to these compounds, whether the element or compounds. These three are the elements, and here these are the compounds. The addition of oxygen to an element or a compound, this compound is called oxidation. This is very simple. I think that you have understood about the oxidation. Second, reduction. So here I have written some equations of the reduction, the reactions. Here FeOC, when this C combines with oxygen, or this oxygen is removed from here, from Fe of ferrous oxide, so the carbon monoxide form. So here in all these reactions, this oxygen is removed by some other chemicals, carbon monoxide, hydrogen. Here HGO, individually when HGO is heated, it is dissociated into mercury and oxygen. So here in this way, the removal of oxygen from a compound, these all are compound, but in the form of oxide, that is called reduction. So very simple. What are the oxidation reaction, oxidation and reduction? Oxidation is a addition of oxygen, and reduction is a removal of oxygen. So in this way, I think that you have understood about the oxidation and reduction. Now, so first of all, here I want to tell you about from where did the then scientists come to know about this definition, that the addition of oxygen into an element is oxidation and removal. From where did the then scientists come to know? The then scientists observed that all the elements are, approximately 90% elements are found in the form of oxide in earth crust. So they concluded that the atmospheric oxygen combines with the element to form oxide, or you can say the atmospheric oxygen reacts with the element to form oxide that is found in the form of earth crust. And again, in the then Kinyagar found how did they extract the iron from the earth crust. So they also, when FeO is heated with coal, then the Fe will be extracted, So in this form, the removal of oxygen from the oxide is reduction, and the addition of oxygen to a element or a compound is called an oxidation. But here, I think you have noted all the equations. Now, I am giving you some more concept of the oxidation. Suppose here we take any other reaction. So here, with the development of the chemistry, the number of elements increased. In the same way, the number of reactions increased. Then the one reaction, I found one reaction that when magnesium reacts with chlorine, then magnesium chloride is formed. In the same way, when sodium is treated with fluorine, then sodium fluoride is formed, 2NaF. And in the same way, when aluminium is 2Al plus N2, here aluminium nitride, Aln. These are the. So here, this definition, can you describe whether these reactions are oxidation reaction or reduction? Because here is only oxygen. This addition, here is a limitation that those reactions in which oxygen takes part, that are called oxidation reaction. But here oxygen doesn't take part. So these definitions have some limitations. These can classify only those reactions in which oxygen takes part. But what about these reactions in which oxygen doesn't take part? So we need to broaden this definition of the oxidation. Now we need. So here again I am telling you the addition number second definition of the oxidation. In this same way, there is nothing. Only some we will add some in this definition. So the addition of oxygen oblique, what is the similarity in O2, Cl2, F2 and N2? These all are the negative part. This is all oxygen, nitrogen and fluorine negative. These are only. Then the addition of oxygen or electronegative part in a substance, substance, whether it is metal or a compound, so in a substance. So addition of oxygen or a electronegative part in a substance is called the oxidation. So here I am giving the oxygen or electronegative part. These are the electronegative part, chloride, fluoride and nitride. So you can give the examples of the electronegative part. Now again I am telling you to extend this definition. I am telling you again the addition of oxygen in a substance and removal of, it is a complete removal of hydrogen or electropositive part, from a substance. Professor, so it is the complete definition of the oxidation. Addition of the oxygen. O means oxygen and electronegative part in a substance, and removal of hydrogen and the electropositive part from the substance. So now you should give the example of these four. You should the addition of oxygen, addition of electronegative part, removal of hydrogen and removal of electropositive part. So I have given the two examples. I have given the examples for the addition of oxygen and the addition of the electronegative part. Now I am giving the example of the removal of hydrogen. What will be the example of removal of hydrogen? Suppose this is S2S. And H2S pass dissolve the H2S in water and pass chlorine. So here 2HCl plus Cl2 will be formed. 2HCl and S2 S here S will be extracted. So if these equations come to your examination and you are asked that justify this equation, this reaction, whether it is oxidation or a reduction. How will you justify it? So you will justify here in H2S, hydrogen is removed from the H2S main substance, then this from sulfur, so sulfur get oxidized. Sulfur gets oxidized into S. So here in this way it is an oxidation reaction. Now I am telling you the what is the example of the removal of electropositive part. You should learn the removal of electropositive part. These are the very few reactions you should learn about this. Suppose we take potassium ferrocyanide, K4FeCN6, potassium ferrocyanide. When potassium ferrocyanide is treated with hydrogen peroxide H2O2, so here two molecules we will take, and here 2K3 FeCN6 plus 2KOH. Here in one molecule there are 4 K atoms. Here 3 K atoms, 1 K atoms is removed from the here. So here removal of electropositive part from this substance. This is an example. So I think this is the complete definition of the oxidation. Now in the same way, because oxidation reduction reaction are just opposite to the oxidation reaction. So here I say here addition of here you will be learning here. In this case here the definition. The definition of the reduction will be replace this addition from the removal. So removal of oxygen or electronegative part from, you will write here part in a substance you can write here to a substance into a substance, or here to from a substance, from a substance. So here, this is the half definition of the reduction. So here, removal of O, removal of oxygen. This is the removal. I am giving the example, and I have given so many examples here. You have written those examples, but now I am again telling you Fe plus C is equal to F. This is the removal of, this is the reduction of the FeO into Fe. So with the reduction of ferrous oxide, we can extract the iron. Again, the electropositive. What is the electronegative part? Electronegative part. Removal of electronegative part. You should remember take an example. I am giving you the example FeCl3 plus S2. When hydrogen is passed in the ferric chloride, so this 2 S2 here, 2FeCl3, 2FeCl2 and 2HCl. This now here this Fe is ferric chloride and here it is ferrous chloride. So the removal of the negative part, one negative Cl3 to Cl2, it is a reduction reaction. In this way, I have given both two examples, removal of oxygen and removal of electronegative part from a substance. And again complete. So here I have written the removal of hydrogen. So you will be right here addition of hydrogen and electropositive part. Hydrogen oblique electropositive part. Addition to a substance. This is the electropositive part. So here to a substance. Now give the example I have given here also. You should know there are 4 examples. Or the removal of electronegative I given. Now addition of H. Addition of H, you will find the equation ethene or ethylene CS2 double bond CS2 plus H2, and here CS3 and CS3. This is the example of reduction reaction. When hydrogen is added to ethylene, the ethane will be formed. So it is the example of a reduction reaction. Now, if question is asked to you that justify this is a reduction reaction, how will you justify this reduction reaction? This is a reduction reaction. There is no oxygen, there is no replacement, there is no only addition of hydrogen is there. So how can you, according to definition, it's a reduction reaction. But how will you justify it? Here you say to justify it, you should explain. Here the carbon is sp2 carbon. This is sp2 hybridized and this one is sp3 carbon. So this is the more electronegative carbon. The more electronegative carbon. It is more because S character is more than sp3 hybridization. So this carbon is more electronegative carbon than this. So here the electronegativity of the carbon decreases. Electronegativity of the carbon decreases. So this reaction is also called reduction reaction. This is the main cause. You can with the help of this you can justify that this reaction is a reduction reaction. Now again I come to the reaction that the electropositive part. So the addition of electropositive part, you can take this example here. HgCl2, it is the more I will discuss this, especially I will discuss you HgCl2 plus SnCl2. When SnCl2 is added in the solution of the mercury chloride, then the grain precipitate here Hg2Cl2 plus SnCl4. SnCl4. Here, here you can write here 2HgCl2 plus SnCl4. So how will you justify here the removal of here the addition of electropositive part? Here Hg is 1, here Hg is 2. So you can give the ratio of Hg and Cl. So here Hg and Cl are found in 1:2. Here Hg and Cl are found in 1:1. So this ratio shows the removal addition of electropositive part. So in this way you can give, my dear students, both the applications are old concept of the oxidation reaction or the redox reaction. I have told you, you should know about the history or the old concept of the redox reaction. I have told you all the reaction. Now in my coming video, I will tell you about the modern concept of the electron gain of electron or the loss of electron are also help us to define the oxidation and the reduction reaction. I will tell you in my next video, and in my coming video I will also tell you about the oxidation number. With the help of oxidation number you can also define the oxidation, but this is the old concept. Now I am taking this example again here. This is the most important and most valuable example for the redox reaction. Now I am telling you that the oxidation and reduction are the two types of the reaction, are two faces of the same coin. You can say where there is oxidation, there is reduction. So in the same equation, in the same reaction, if oxidation takes place, there will also reduction will also take place in this way. So I will explain from this example. Here suppose 2HgCl2 plus SnCl2. So here in this case the 2Hg2Cl2 plus SnCl4. Take the example of SnCl. This is SnCl and this is SnCl4. What change is there in SnCl2 to SnCl4? This is an addition of the electronegative part, because here chlorine are 2 atoms, here chlorine are 4 atoms. So when addition of the negative part takes place, the reaction will be called as oxidation reaction. This is oxidation reaction. Oxidation. So I am saying, when the positive part of the substance is decreasing or there is addition of the positive part, so here this is the reduction. This is reduction reaction. So I am saying to you, here there is a oxidation. Where there is oxidation, there will surely be a reduction. So here, oxidation and reduction reactions will go simultaneously. The oxidation and reaction will go simultaneously. In this way, now you can write here 2Hg positive, 2Hg double positive plus Sn double positive. Right here, Hg2 positive plus Sn plus 4 positive. This equation tells about the thinking about the next concept of the electron configuration, electron gain or loss. When an element, an atom gains electron, it means it is on gain of the electron, the direction or the loss of the electron will be called as oxidation. I will tell you in my further video, coming video, that the concept of the electron gain and loss about the oxidation reaction or the oxidation reaction. I think that you have understood the preliminary knowledge of the oxidation and reduction. This will help you if any question is asked in your examination, then you can write frequently about the answer of that question. Now in my coming video I will tell you the next concept of the electron concept or the oxidation number concept. I think that you will learn a lot from this video. Please do like my video, please share it here the video and watch the whole video. If you watch the whole video, then you will understand what I am going to tell you. So please watch and share and like my video. Thank you very much.